Okay, let's solve another problem. We have here, the steel truss supports a 6,000 pounds load as shown in the figure. The cross-sectional areas of the members are given 0.5 square inches for member AB and 0.75 square inches for member BC. Compute the horizontal displacement of point B, and then we will use modulus of elasticity E equivalent to 29 times 10 raised to 6 psi. So first one, let's solve first for the axial load applied in member AB and member BC. And to do that, let's draw first our free body diagram. So just consider node B or point B. Meron siyang tatlong force na naka-apply doon. First one is load P, 6,000 pounds. And then we have the axial load of AB and axial load of BC. Pero, hindi pa natin alam yung direction ng force kay AB and then BC. Pag hindi nyo po alam, pwede pong mag-assume. Okay lang po yun. Pag positive po yung nakuha ng mga values, ibig sabihin tama po yung assumption ng direction. Pag negative po yung nakuha, ibig sabihin mali po yung direction. Pero yung value, yung ating magnitude value, tama po. Considering that there is no friction. Okay. So assume natin yung member AB is tension, the load in member AB, and then yung BC ay compression. Load in member BC. Yung force in member AB naka-incline po. So meron siyang slope doon. 9 yung height and then 12 yung run. 9 yung rise. So, i-lowest form lang po natin siya. Yung mga values na yan, 9, 12, 15. Divisible by 3. So, 3 ito, 4. Ito ay 5. Okay lang naman pong gamitin na 9, 12, tsaka 15. Wala pong magbabago sa sagot na makukuha. So, since meron tayong free body diagram, we can now solve for the forces in member AB and member BC. First one, let's solve first for member AB. Bakit yung member AB? Dahil yung member BC ay horizontal. So, para ma-eliminate po natin yung member BC, horizontal yon, magsa-summation of forces tayo muna kay vertical axis para hindi natin maisali yung ating unknown na isa, which is member BC. So, taking upward forces are positive. Yung component ni member AB, vertical component, ay pataas. So, that is positive force. Paano makuha yung kanyang vertical component? May slope tayo, that is 3:5 of member AB. And then, meron tayong downward force, negative 6,000. And that is equivalent to 0. So, solving for member AB, that is 6,000. Transpose nyo lang, cross multiply, times 5 divided by 3. So, member AB is positive 10,000 pounds. Since positive po inakuha natin for member AB, sabihin tama yung ating assumption ng kanyang direction, that it is a tensile force, or that is in tension. And then, taking summation of forces along horizontal, or X, equivalent to 0. Taking to the right forces are positive. Yung horizontal component in member AB is going to the right, therefore positive. Ano yung horizontal component? 4/5 of PAB. And then, we have negative PBC equivalent to 0. So, substitute lang natin or transpose lang natin to, magiging positive. And that is 4/5 of PAB. Na-compute nyo na 10,000 pounds. So, PBC is equivalent to 8,000 pounds. Positive din po yung nakuha natin. Ibig sabihin, tama po yung in-assume natin direction that it is in compression. So, ano po ba yung indication ng direction natin? Yung member AB is in tension. Ibig sabihin lang po nun, kapag na-deform po yung ating member AB, since tension yung ating force dyan, or applied, or axial load applied kay member AB, ibig sabihin, magkakaroon tayo dyan ng elongation. Kay member BC, since compression yun, yung force, ibig sabihin, makokompress po yung ating member BC, liliit po yung ating bar BC. So, yun po yung indication ng ating directions for our forces. Para mas ma-drawing po natin ng mas maayos yung ating deformation system. Para mas maayos po, or para mas makuha po natin yung ating unknown po natin for the deformation. Dahil kapag mali po yung ating galaw, hindi po natin na-analyze yung kanilang direction, magiging mali rin po yung ating makukuhang sagot. Dahil hindi po natin mas maayos, hindi po natin ma-drawing na maayos yung ating deformation system. So, mamamali tayo kay compatibility equation. So, para may drawing natin yung compatibility equation natin, may analyze the deformation system. So, gagalaw daw yung point B. Ito yung initial position ni point B. And then yung member AB dito, yung member AB dyan ay tension daw. Ang sabi natin kanina, kapag tension yung force doon, hahaba. Ito yung member AB natin. So, hahaba lang yung ating rod. Ganun daw. And then, yung member BC natin dito, compression yon. Ibig sabihin, liliit. Bar. Ibig sabihin yung point B, pupunta doon. Liliit, mako-compress. Yan po yung deformation natin. So, this is deformation of AB and then deformation of BC. And then, kapag na-drawing natin yung ating deformation, meron siyang galaw. Kapag nagdo-drawing po ng deformation system, kailangan po nating ma-drawing yung ating deformation kung nasa mismo mag-aak and then yung galaw, yung kaniyang displacement po. Yung deformation po is with respect to the axis of the length. And then yung galaw po ng system po natin or ng ating bawat bar is perpendicular palagi po sa kanilang length. So, yung member AB nandito, may deformation siya with respect to the length and then yung galaw niya is perpendicular to the length. Magdodraw lang tayo ng perpendicular line dyan. This is 90 degrees. And then, for member BC, ito yung deformation niya and then yung galaw niya is perpendicular to the length. So, member BC, ito yon. And then yung galaw, perpendicular daw po. That is 90 degrees. Ibig sabihin, magko-coincide po yung ating deformation system sa point na to. Ito na yung final position ni point B. Denote that as point B. Ang tanong sa problem is, compute the horizontal displacement of point B. Yung point B, ito yung initial position, ito yung final position. Ano daw yung horizontal displacement niya? Yung horizontal distance niya. So, compute lang natin yon. Papansin naman natin, ito yung point B, ito yung initial position ng point B, ito yung final position ng point B. Yung horizontal displacement between these two points is the deformation of BC. So, yun po yung ating magiging unknown sa problem. Take note po, the horizontal displacement of point B is equivalent to the deformation of BC for this system only. Not always ganyan po yung magiging equation nyo. So, para masolve po natin yung unknown, solve lang po natin yung deformation kay member BC. So, that is PL over AE. So, yung load ni member BC, na-compute nyo na, 8,000 pounds multiplied by the length of BC. Ito yung BC natin, naka 12 feet. Gagawin lang po natin yung ating units na naka pounds tsaka inches para maging consistent po yung units natin. Therefore, multiply natin yung 12 feet. Gawin natin inches, that is 1 foot is to 12 inches. Cancelled na. Over the area of member BC is given in the problem, 0.75 square inches multiplied by the modulus of elasticity, 29 times 10 raised to 6 PSI or pounds per square inches. Cancelled yung pounds, cancelled yung square inches, ang unit will be in inches. So the deformation of member BC, which is also equivalent to horizontal displacement of point B, is equivalent to, solve lang po natin yan by calculator, 0.05297 inches. And that will be the requirement for this problem.